There is a system underneath some of the world's biggest cities that most people know nothing about. It runs 24 hours a day, every single day of winter. And in the coldest months, millions of people's lives quite literally depend on it. This is district heating. And it's one of the most important and most forgotten pieces of infrastructure on the planet. Picture a massive power plant sitting on the edge of a city. Inside, giant furnaces are burning sometimes natural gas, sometimes waste, sometimes biomass. And they're producing something very simple: hot water. We're talking temperatures between 80 and 130 degrees Celsius. Then water gets pumped through enormous insulated pipes buried under the streets, under the roads you drive, or the parks where kids play. A silent underground river of heat flowing 24 hours a day, 7 days a week. And here's where it gets clever. When that scorching hot water reaches your neighborhood, your apartment block, it doesn't actually enter the building directly. Instead, it passes through something called a heat exchanger. Think of it like a handshake between two separate systems. The city's hot water on one side, the building's internal heating system on the other. They never mix, but the heat transfers perfectly. Your radiators warm up, your floors heat up, your hot tap water gets warmed, and then that slightly cooled water gets pulled back through a second pipe, a return pipe, all the way back to the plant, where it gets reheated, and the whole cycle starts again. No boiler explosions or carbon monoxide risk in the basement. Just a reliable and invisible system. Now, you might be thinking, okay, that sounds smart, but how big are we actually talking here? Warsaw, Poland. Warsaw's district heating network stretches over 1,800 kilometers of pipes. That's roughly the distance from London to Moscow, all of it buried under one city. The system serves around 80% of all Warsaw residents. Entire districts, apartment complexes, hospitals, universities, all connected to one giant network. When winter hits Poland and temperatures nosedive, Warsaw doesn't panic, because the city already solved that problem decades ago. Copenhagen, Denmark. Copenhagen's system is so advanced, so comprehensive, that it covers nearly 98% of the city's heating demand. Think about that number. Almost the entire capital of Denmark, warmed by one connected network. They've spent years transitioning the energy source that feeds this system, away from fossil fuels, toward geothermal energy, heat recovered from data centers, even heat pulled from the seawater surrounding the city. Copenhagen is turning its heating grid into something that feels like science fiction, except it's already working. Stockholm, Sweden. Stockholm built one of the world's most sophisticated district heating systems and then quietly made it smarter. One of the key innovations? Waste heat. The heat that would normally be thrown away by industrial processes, by supercomputers running data centers, even by the Stockholm metro system, all of it gets captured, redirected, fed back into the network. In Stockholm, heat that was about to be wasted becomes warmth in someone's apartment. The Swedes essentially turned energy loss into energy gain. Moscow, Russia. Moscow operates the largest district heating network on the planet. The system serves over 11 million people. That's more than the entire population of Portugal, all being heated by one interconnected grid. The pipes stretch so far and run so deep that the network has its own dedicated teams of engineers, thousands of workers, whose only job is to monitor, maintain, and repair the system 24 hours a day. Because in Moscow, when January arrives and temperatures fall to -20, -25, sometimes colder, these cities don't just use district heating but depend on it. Remove it, and you have a humanitarian crisis. So why did this system get built in the first place? Why did city planners 100 years ago decide to run thousands of kilometers of pipe under their streets? 3 reasons. First, extreme climate. Cities in Northern Europe and Russia faced winters that could kill people caught outside. That level of cold demands a system that works every single time. A centralized solution, one that heats the entire city. Second, urban density. Think about a city like Moscow in the 20th century. Millions of people packed into apartment blocks, tower after tower. Now imagine every unit running its own boiler, its own fuel and own maintenance. The logistics collapse immediately. Fuel deliveries to every building, every week, through snowstorms, and the fire risk alone becomes unacceptable. Centralization was not just more efficient. In cities that dense, it was the only system that made sense. Third, efficiency. Here's something that surprises most people. One large, centralized heating plant is dramatically more efficient than thousands of small individual boilers doing the same job separately. A big plant can capture heat that small systems waste. It can be tuned and optimized constantly. It can use fuel more completely. When you combine all of that at city scale, the energy savings are enormous. And back then, nobody was talking about saving the planet. They were talking about saving money. District heating didn't emerge because city planners were visionaries, but because the alternative was simply not sustainable. Because district heating, especially the massive Soviet-era systems that still run across Eastern Europe and Russia, comes with some very serious problems. And understanding those problems is what makes this story genuinely fascinating. Many of these networks were built in the 1950s, 60s, and 70s. The Soviet Union constructed enormous district heating grids across dozens of cities: Warsaw, Kiev, Minsk, Riga, Tallinn, as part of its centralized planning model. At the time, it made sense. But those pipes? Many of them are still in the ground. Decades of pressure, freeze-thaw cycles, and deferred maintenance have left parts of these networks in serious condition. Pipe failures happen. In the worst cases, superheated water breaks through the surface, damaging roads, flooding streets, and in rare, tragic incidents, injuring people. In Russia alone, aging sections of the heating infrastructure lose anywhere between 20 and 30% of the heat they produce. Direct leaking, poorly insulated pipes buried under Soviet-era streets. In the worst-maintained systems, that can climb to nearly a third of all heat generated before a single radiator ever warms up. Imagine running a business where nearly a third of your product disappears before it reaches the customer. That's the reality of some of these aging systems. Large parts of Eastern Europe's district heating still run on coal or heavy fuel oil. Systems that made economic sense decades ago now produce emissions at massive scale. And shifting away from coal is not a simple upgrade. The plants change, the networks change, the pricing and contracts change. Everything has to move at once. It is a full system transformation. Here's the uncomfortable truth about any centralized system. When it works, it's magnificent. When it fails, everyone fails together. A critical pipe rupture in the wrong location can cut heat to tens of thousands of apartments simultaneously during a bitter cold snap, with elderly residents inside. The city of Kharkiv in Ukraine experienced a catastrophic breakdown of its heating infrastructure during the winter of 2022 to 2023, and the human consequences were devastating. At the exact same moment that some old Soviet-era networks are crumbling, the concept underneath them is quietly becoming one of the most exciting ideas in sustainable urban planning. Cities across Scandinavia are pulling heat out of the ground. Geothermal energy tapping into the Earth's natural warmth is being fed directly into district heating networks. In some locations in Iceland, entire cities are heated almost entirely this way. Zero combustion and zero emissions. Just heat that's been sitting in the Earth since before humans existed. Every data center on the planet is fighting the same problem. All those servers, processing billions of calculations every second, generate massive amounts of heat. Heat that has to be removed constantly, or the computers overheat and fail. Traditionally, that heat just gets vented into the atmosphere, wasted. In Stockholm, Helsinki, and Paris, engineers are already doing exactly this, capturing the heat pouring out of data centers, redirecting it into the district heating grid. The same heat that would have been thrown into the sky is now warming apartments. The data centers get cooled. The city gets heated. Nobody burns anything extra. Stockholm's grid captures heat from their metro tunnels. Copenhagen pulls thermal energy from the seawater in the harbor. Paris is expanding its ancient district heating system to cover more of the city, running it increasingly on recovered energy. Sensors across thousands of buildings constantly feeding data back to a central system. AI algorithms predicting exactly how much heat each neighborhood will need hour by hour, based on weather forecasts, building occupancy, time of day, storage tanks the size of grain silos holding excess heat from the summer months, ready to release it in January when demand peaks. For a century, district heating was seen as a relic, something built by Soviet planners or pragmatic Scandinavians to solve a local winter problem. A practical solution, but hardly glamorous. Hardly the future. But now, as cities worldwide scramble to decarbonize, as electricity grids struggle to handle the load of millions of electric heat pumps, as urban populations keep growing and energy prices keep climbing suddenly, the idea of a shared, centralized, intelligent heating network looks less like an old solution and more like the most underrated infrastructure idea in the world. The pipes are already there, in Warsaw, in Moscow, in Copenhagen, in Stockholm. Millions of kilometers of underground network, moving heat silently through some of the coldest cities on Earth. The question is, which cities will figure out how to make it clean fast enough? And the cities that get that answer right might just have cracked one of the most important puzzles of the next 50 years. And if you enjoyed this, the next video is about something much bigger than most people realize. India is currently building one of the most ambitious AI hubs on the planet. And the geopolitical shift happening behind it, almost nobody is talking about. That one's up next.